So good afternoon. I'm Beetle, otherwise known as Don Bailey. I'm a principal geek with the Amazon Web Services security team.
And I'm Brian Wagner, something of a road warrior for AWS Professional Services.
This is SEC313, automating security event response from idea to code to execution. So today's talk is the latest iteration in a string of talks that we have presented to help customers understand how to monitor and defend their AWS environment. We're focusing heavily today on security automation, and we'd like to present a methodology that will help you take your own ideas from the drawing board to actual reality. Now, when it comes to building security automation, there are many AWS services and features to choose from, so Brian and I are going to help you decide which ones to use to achieve your security objectives. And we're going to present a number of key concepts, but a fair bit of what we're doing today is demonstrations and code, so that's pretty cool. And we're also going to make sure that we point out additional resources for you to continue your educational journey down the realm of incident response. And we will have demos.
Demos indeed.
In fact, let's go ahead and start with one.
Let's start with a demo.
Yeah, absolutely. So never before seen on YouTube. We did this at the Sydney Summit, so only on SlideShare, and it just doesn't have the same effect.
It doesn't.
Who here would like to be Chief Information Security Officer for just a few seconds?
Oh, come on.
Responsibility, right? It's a lot
it is a lot of responsibility. You can do it, I promise.
Come on, can I get a volunteer? There's somebody, okay. Now,
hey, we got one.
real quick.
Oh, that works too.
We have to check. Are you qualified to be a Chief Information Security Officer? No. He says no. Can you push a button? Yes. You're qualified to be a Chief Information Security Officer.
Oh.
Don't tell my boss. All right.
I hope that's a CISO
You push that button. And let's see what happens.
I'm going to switch over. What did you do?
Oh, congratulations, sir. You've just violated a number of international laws in hacking. That was an automated penetration test against Brian's account.
Yes.
And we're going to check out and see what it actually did.
Oh, no. All right, so let's zoom in. What did we do? Based on the logs, well, the button was clicked, so good job there.
Yep.
We stopped CloudTrail. So we turned the cameras off, right, like in the movies. Now we elevated access by using power user access. And we elevated one further with an inline policy that we called admin. And that was attached. So that actually all happened, and right from the push of a button.
Switch back to
Oh, yeah, sorry.
slides.
We should switch to slides so you can actually see what we're doing.
We'll get this down.
Yeah, we will.
So we like buttons, and we like doing automated things with buttons. That's awesome. I actually think that's the first time somebody's done a demo at the beginning of their presentation, so hopefully that's at the stage. We'll do some more.
Yeah, and the idea there is to kind of warm you up to what's achievable, right, on the platform.
And it's push button security. So I think, if we have a few more of these, I could probably build like a dashboard for the boss, and he could just start mashing buttons.
I think that's a terrible idea. I think it'll make your office, your coworkers scurry around.
Yeah, it's probably not a hot idea. No, you're right. No. But I'm a security geek. I think IoT buttons for like security things are much cooler than like reordering paper towels.
Yeah, they are. But this is a programmable dash button essentially. If you guys know what a dash button is, it was like so you can reorder paper towels and stuff like that. This is a programmable version of that, so it just makes it so much cooler.
The IoT button, and people can buy this right now.
They can. So if you want to buy a button, you go to aws.amazon.com/IoT/button, click Buy Now, the Buy Now button to buy a button.
Right.
Yeah. Yes.
As we mentioned in the demo, this button is just a trigger mechanism, and it's for things that we're doing with Lambda.
Indeed. So Lambda's our workhorse here. I mean, you saw the logs. If you work with Lambda, that's where the logs end up. It's really helping us get things done. If you're not familiar, it's one of our newer services, really based in serverless compute. So the idea is that you don't have to have some code, some EC2 instance running idly, waiting for code to be executed, right? So you just throw it in Lambda and it'll do the work for you.
I like to call it execution as a service.
That is a terrible name, very threatening.
Get stuff done as a service.
Much better, thank you, thank you.
Yeah, the marketing guys like that. So what else have we talked about at previous reInvents that you guys should catch up on in your off time? Because we're not going to go through all of that, no. Right? We've got a number of different concepts that we'll go over in this talk, but if you want to get the prereqs, make sure you check out what we've already got on YouTube, right? So what are some of those things that we'll...
Yeah, so those talks kind of covered things about detection and response, right? And like the building blocks that we talked about, something like security roles, config rules, CloudWatch, so those kind of tools.
And if you want to learn more about intrusion detection in the cloud, or incident response in the cloud, or wrangling security events in the cloud, you can search for those terms on YouTube. You'll find these presentations. I'm not a TV star, but I play one on YouTube. We've seen a cool demo, and that's neat. We've got buttons. We're doing CISO-like things with the buttons.
Yeah.
But let's take a step back. Let's think about what we're actually trying to accomplish today, why we're doing that, how we're going to do that. You've probably seen this before, right? The shared security responsibility model. And we, AWS, are responsible for security of the cloud. That's from concrete to hypervisor, API endpoints, the services themselves, authentication, authorization, encryption mechanisms, compliance of all of that. And yes, we have all of the compliance flair.
All the flair.
We have all the flair. We do a lot of what we like to call undifferentiated heavy lifting for our customers, particularly in security, deliver an environment that you can use to build awesome experiences for your customers. And then you as customers, you're responsible for your security as you operate in the cloud. So using the platform securely, operating in a secure manner, using the services and mechanisms we provide to do that. But there's quite a journey, and we're expecting our customers to be able to complete this journey to get to where we are as a company, and also where our most secure customers are when it comes to operating in a secure manner. So consider this a customer security capability maturity model circle of life symbol, right? Notice that there's an evolution we want all of our customers to experience. It starts with simply understanding the security best practices, moves to enabling detective controls, well-crafted protection for your communications and your storage, change management like a boss, right? And eventually automating security to turn the tide versus adversaries, right? The idea that we're fighting guys that are on the internet, or maybe the intern that's creating typos, right? We're steadily making this journey more accessible, more comfortable for our customers, and AWS partners are also delivering a number of solutions to help here too. But at the end of the day, right, security is in your hands, right? Your fate is in your hands. We think that that's for the better, mind you, but security is not one size or solution fits all, so we can't just dictate that for you. There are things that you might have to build, and you have to get things done. So you use the Legos, right? Unique to your business, maybe your compliance requirements require you to do different things with different services. And we have a lot of services and features, as you can see from this export of our org chart, the AWS Management Console. You decide which ones you want to use, right? How you're going to operate. And that includes the level of risk that you're willing to accept. Ideally, you want to minimize that by taking the journey that we just mentioned. Now, we understand that there's a smorgasbord of the services and features. We look at them as building blocks, as I mentioned, Legos, picking and choosing the shapes, the sizes that we want to use, the colors we need to achieve our security objectives. For us, and for many of our customers who are builders by nature, this selection is not daunting. This is actually enabling for us. And it's important as security leaders within your own organizations that you embrace this view, right? When we say choose your own adventure, that should be exciting for you. You have a real opportunity to express and enforce your security policy, your controls, in a manner that's never been afforded to you before.
Exactly, and we really do mean choose your own adventure, right? So there are really multiple ways to get to where you want to go. So really at the top left, sort of the high level, you have your staff or whoever interacting with AWS APIs, right, with endpoints. And then you have AWS capturing that activity via CloudTrail, and we're storing it for offline use, or you're storing it for offline use, or maybe even filtering interesting events, and that's what we're sort of here to talk about today. So you can store them, crunch through them at your leisure, or maybe you have to for compliance purposes, right? So CloudTrail is really meant for auditing. So you can subscribe to something interesting from CloudTrail. That's what we're talking about. We're going to react to it. So the output of those functions on the far end, right? So we're talking about listening to interesting events. That's where the CloudWatch events comes in, aptly named. And then what do we do with it? We don't have to just store it. We can actually do something about it. You can take actual real action using carefully scoped roles and credentials to enforce your security policy at scale. So that's what we're here to talk to you about today.
So let's break down the methodology. We're going to start with questions that you're going to need to answer for yourself. Right? These are the guiding questions that are going to help you take an idea that you have, something that you would like to accomplish from a security objective standpoint, and actually make that reality, right? We're going to enforce your security policy. We're going to do it at scale. Make that a reality. What is my express security objective in words? Write it down. Get that actual idea written down. Understand in simple terms what it is we'd like to accomplish. Is this something that's configuration or behavior related, right? Is it static, associated with the AWS environment, or is it dynamic, associated with the AWS environment's behavior? Then find out what data you're actually going to need to support your activity, right? Not only what data is going to support it, but where is it resting? Then do you have access to it? Establish access to the actual data that you'll need to make decisions. You also want to think about performance requirements. Is it something that you want to accomplish now? Something that you want to accomplish later? Something that you're going to accomplish on demand? And then what mechanisms actually support the above, right? We talked about all the services and features and the Legos and putting those together, but which services support the idea that you actually have in getting that accomplished? And then again, we want to get this written into code. We want to express our security objectives as code and get this accomplished. So let's start working through these questions and dive a little bit deeper. So our security objective, right? Writing down what we would like to accomplish. Here are some examples. I would like to push a button that launches a penetration test on my AWS environment, right? That's where we started with that idea. We didn't start with like the button and like work backwards from the button. We worked backwards from an idea that was written down in simple language. I want to know when someone turns off CloudTrail, and I want it to turn automatically back on, right? I need to prevent my developers from launching EC2 instances from Amazon machine images that are not approved, right? These ideas are fairly simple. Nobody's going to spell it out for you in PCI. Nobody's going to spell it out for you in FISMA, right? These are your goals as a security engineer, as a security manager, as a security leader within your organization. You want to accomplish these things. Write them down, and let's code them up.
Right, so as Beetle said, you really have to determine if you are keeping an eye on something configuration related, or are you really looking for a particular resource or user behavior that you're concerned about, right? So it's really identifying in plain English, what you're after. And the fundamental difference between those two things is really in two services that we have called config and CloudWatch. So if you're not familiar, like config keeps an eye on your infrastructure as a whole from a configuration perspective. Again, aptly named config. So things like security groups and NACLs and EIPs, instances launching, coming on and offline, things like that. And it can give you a point-in-time look, or even like a span-of-time look at the changes in your configuration of your environment as a whole. And while you're looking at those things at a point-in-time perspective, you can even roll back those changes in batch, right? So you're saying, if this EIP was here and it shouldn't have been, or this security group was attached, you can just sort of undo that and roll it all back. And what's even cooler about config is that, we've been talking about listening for interesting events. Well, those rules, those changes, it can listen for those, and you can take action on them. You can validate them, or you can notify out, or even roll back those changes. CloudWatch, on the other hand, is detailed metrics on resources that you define. So you really have to call out, I'm interested in that, I'm interested in that. It's not, not as much infrastructure as a whole. So a lot of our services come with CloudWatch metrics out of the box. For example, EC2, you can right away look at CPU usage or network I/O. DynamoDB, you can look at throughput on a table or an index. Or SQS, you can look at things like queue depth. So any of those are all metrics, right? And what's even cooler about CloudWatch is you can create your own metrics, right? So once you have a metric into CloudWatch, you can alert on that metric. And when you have an alert on a metric, you can do really cool stuff with it. For example, it's not security related, but EC2 autoscaling. If you're not familiar with the underpinnings of that, what happens by default when you ask for autoscaling to happen, it sets an alert, a trigger, an alarm, on when your aggregate CPU for that group goes over 50% for 5 minutes, I think. And then it creates an alarm, which triggers your autoscaling, and it will give you more instances in order to meet your new demand. So what you can do with your own metrics is something like that, something, react to some change in your environment. And that's what we're proposing here. So was anyone at the Security Jam yesterday? Was anyone there? Yeah, I recognize a few faces. Yeah, so we had a good time there. So Challenge 8. I know most of you weren't there, but Challenge 8 was DynamoDB being called from API Gateway. And I created a metric from the logs that API Gateway was outputting all the data being pulled out of DynamoDB. and I created a metric to look for something interesting. In this case, it was a data field that I just called secret data, right? So the whole thing was to kind of look for data loss. And what happened was every time the logs spawned this piece of data, this secret data field, it would create a metric with a value of 1. Anytime, then I got to create an alert that said anytime that metric is greater than 0, I want to trigger an alarm. So that's the kind of stuff that we're talking about when we say interesting events. And with those alarms, we can do really, really cool stuff.
So it's almost like you placed something sneaky in the database and just waited for somebody to try and sneak it out of the database.
Exactly.
I like it. Yeah, I like it. So it sounds like an 80s commercial, but where's the data? Right? Where is it? Is it coming out of something like CloudTrail where we're monitoring API activity? Right? Is it something that's more dynamic or real-time coming out of CloudWatch? Is it associated with the AWS environment and the instance's behavior like CPU cycles or network I/O? Or is it associated with data that's coming from your CloudWatch agent on an instance associated with an application? Right? Are we talking about something dynamic but run by somebody else? Right? Amazon Inspector. Somebody ran Amazon Inspector, delivered some data to somewhere, a report, findings, et cetera. We need to get that data, right? Or trusted advisor. There's an API for it, right? There's a dashboard for it, but there's an API. Have you queried the API? Have you delivered the data to somewhere, right? And then, of course, there's other things that aren't even associated with APIs or instance behavior, but network flows, right? So now we're down to like VPC flow logs. Where's that data? In many cases, you're going to find it in S3, right? We choose S3 as the place that we're storing things, but you may have like pre-processed it, post-processed it, and now you're trying to find out where somebody else put it. Locate the data. Find out where you're going to actually take that in, understand it, and start making decisions with it.
Right, so now that you know where the data is theoretically, or at least know where it's going to be when it gets there, you need to make sure you're able to see it, right? Or you know, in the context of this, whatever is going to react or look at that data needs to be able to see it. It needs to be able to access it. And we do that through identity and access management. So that's that logo on the far left. And we have two fundamental concepts here in play, which would be roles and permissions, or policies, I guess, in this case. So roles are a way to delegate access to apps or services or people as well. And when they are assumed, so the verbiage there is assumed, right? So you assume a role or a service assumes a role. When the role is assumed, temporary credentials are issued right then and there for whatever has assumed it. So now you have these credentials to call AWS APIs. So in context of this, what I'm going to call responders, we're going to hear that word a lot today, responders. Your responders are not human beings in this case. We're talking about automation, right? These are machines. These are Lambda functions, most of the cases. And those need to be able to have those permissions in order to consume this data and act upon it. Now the permissions model, if you're not familiar with IAM, we've abstracted what we call policies. There was once upon a time when policies were inline. You had to burn a policy into a user or a role. Now we've been able to abstract policies into their own resources. And you get what's called an ARN, or an Amazon resource name, for a policy. The reason that's important is if you have something in Amazon and AWS that has an ARN, you can control that ARN through IAM policies to say you're allowed to attach this policy, you're not allowed to attach this policy. And we saw that from the IoT button attack from our CISO. Right, so the first thing, and we'll break that down later, but the first thing you saw was he attached something called power user access.
You also have to decide your performance requirements, right? What are your performance requirements? Do you need something done now? Do you need something done later? Do you need something done whenever? When we talk about now, we're talking about mechanisms that allow us to consume data and alert on it in a real-time fashion. So that's going to be CloudWatch. Right? If we're talking about later, and we're talking about time windows of 15 minutes, half an hour, a day, a month, a quarter, right? Then we can have CloudTrail activity sent to an S3 bucket, something that gathers that up every once in a while, reads it, performs some sort of action, right? Or whenever, right? An ad hoc activity, right? A query to the Trusted Advisor API, somebody running Inspector and delivering results. Again, if you need something done later, now, whenever, you have to decide that from a performance requirement standpoint and realize there are different services that are going to give you that different experience.
Absolutely. So now we sort of know where it is. We know when we need it. By this time, we've sort of made some decisions. So now we need to think about what services are going to help move the process, the data basically, and process it, right? So we find out where it is and when we want to do it. So now we have to facilitate that to actually happen. And we want to get those through to our watchers and eventually downstream to our responders. So we have these different logs in different places. Beetle mentioned them, flow logs, CloudTrail, whatever, even your own third-party logs if they're dumping to S3, or even if they're not dumping to S3. But it's different information, right? These logs are for different purposes. They contain different information. And ultimately, they are different formats, right? So now, how are we going to relate these logs? We need to find a way to process all this stuff. So you may want to transform them into something normalized, right? So all the logs sort of look the same. You may want to aggregate those. That might be what's important to you if you need to look at a combination of this data. So you have to think of services, again, based on your throughput, based on your when. Services like Kinesis, which can do stuff in real time. EMR, Elastic MapReduce, right, as a service. That will help you crunch logs and find similarities in logs and things like that. Or something that I built recently with some other colleagues, which was based on Elasticsearch. We put all of our logs in Elasticsearch, and we're able to do awesome queries on our data and find stuff that we had no idea was related. So now that we have it, what do we do with it? So it's going through Kinesis, it's going through EMR, it's going through your Elasticsearch. So what do we do? Well, we have some choices, right? We have observe and report, probably the most common one. Maybe you want an alert on your phone. Maybe you want an email. But ultimately, again, we want to do something about it, right? That's ground zero. Just knowing about it is one thing, but let's do something about it. We know certain policies don't even need human interaction, like CloudTrail, for example. That's an easy one. We always want that on. So we don't need to ask somebody, hey, should we turn that back on? Yes, you should. So we're talking about doing that immediately. So with Amazon, with all of our API endpoints and stuff like that, once you get to that observe and report level, and we talked about things like creating alarms for metrics, well, let's put all that together through SNS or other services that can sort of give a nudge to downstream, right, to your watchers, to your responders. So if something happens, we create an alert for it, and that alert can trigger an action, right? So one of my favorite things, by the way, so a good example to kind of get your head around this before we get into the demos, is if your trouble ticketing system, if it has an API, you can actually send an event to that and page out who you need to. In fact, that is the only way to get Beetle to have lunch with you.
I agree.
Yeah.
Now, we're fans of Lambda. We've said that a few different times. We are Lambda fanboys at this point.
Yes.
Right?
Yes.
But the console is absolutely a valid place to go and point and click, prototype something, right? So don't feel bad if you need to dive into the console, look at a couple different services, set your alarms, look at the metrics, set your alarms manually, find out what you'll need to actually trigger something. Eventually, you'll want to move to using code that actually gets your intent done, right? So point and click in the console, absolutely a valid experience, way to go about getting things done, but try and move towards actually writing code and actually getting it done in Lambda.
Right. So this is going to be our basic anatomy. This might get more complex or swapping out services, but generally speaking, this is the flow of how we're going to achieve automated incident response, right? So you have your adversary or intern mashing buttons. You have your environment, right? They're making API calls. This is sort of your choose your own adventure, right? I've sort of simplified it. Events. Everything we're going to do today is going to be based in CloudWatch events. That might not be the only way to do things, but that's what we're going to use today. And those events can trigger anything. So what we're going to call responders, we're going to use Lambda. Again, we are big fans of Lambda for the reasons we mentioned earlier. It's a workhorse. So let's get into some demos and put the stuff in action.
Yeah, absolutely.
Came here for demos, right?
Yeah.
Good.
So,
excellent.
The first one, and part of our IoT button mashing demo,
yes. Ooh,
right? We had an attacker, or in this case, a simulated pen test, that was turning off CloudTrail, right? And when somebody does that, we want to turn it back on and do it in an automated fashion. So if someone turns off CloudTrail, let's turn it back on. How are we going to get that done?
Exactly. So what I'll do to make it easy for you is I'll show you how it happened. Oh, no, actually, you know what? I'm not going to show you how it happened. Not yet. Sorry. Just kidding. I'm going to tell you how it happened, then I'm going to show you how it happened. So
you sure?
Yeah, I'm sure now. I decided. I just decided. So, right, we're going to follow that anatomy. Attacker, or CISO in this case, thank you, he clicked the button. What did the button do? Step one, turned off CloudTrail. We saw it in the logs, didn't we? We said it turned off CloudTrail.
In the API, it looks like.
In the API, it looks like that. So that's the verb, right? It's CloudTrail stop logging. That's the command that it ran to do that. So what I've done ahead of this is create a rule. This is the sort of the fundamental of CloudWatch events, is creating a rule. So these events are happening, and this is what we mean when we say, what is interesting? Let's listen for something interesting. This is actually the rule that is running this demo, right? Let's break it down. Detail type, AWS API call via CloudTrail, right? We look at the event source, which is clearly CloudTrail, and the thing that is interesting to us is the event called stop logging. That's way more interesting than start logging. We want to know when it stops.
But what do we want to do?
What do we want to do? So by that rule firing, we have triggered a responder, and we provide the responder with the relevant data. In this case, CloudTrail stop logging. There's more code than that to it, but the end result is CloudTrail start logging. And that's the Python version, by the way. That's why it looks a little different. So let's see what happened. Did you switch over? You're trying to switch it over? Did it switch it? No? You're not doing it? It's not blinking anymore, is it? There we go.
Yep.
OK. So here's the API. This is the CloudTrail. If you've never seen CloudTrail, this is the actual API, CloudTrail. You can sort of see evidence by, I don't know, that timestamp's a little bit skewed. But you see the username is IoT attack, right? So you attack, there's the attack function, and there's the CloudTrail responder.
I love
you can see
when
RE.
attackers do that.
Yeah, if they call themselves out like, hi, I'm an attacker. I'm just attacking you, if that's OK.
Exactly what's going on.
So if you see where I'm highlighting, so of course there's some residual stuff in there. But the highlight over there is stop logging. Isn't that what we were looking for, right? We were looking for stop logging. And that was step one. We stopped logging. And you'll see the other stuff that happened in there, which we'll get to. But then you see at the very top, start logging. And if you notice the time difference here, we're looking at 2 seconds. The reason why I'm showing you this in here as opposed to the CloudTrail console is because it would happen so fast that it would, by the time you refresh the page, nothing would have changed.
But our performance requirement here was to get something done soon.
Soon, very soon.
Not later.
Exactly. Excellent.
So let's look at another part of the IoT demo that we had. Our second component, the idea that we're going to create or use a different policy than a managed policy, right? Something that's not approved. So if we only want to allow approved managed policies for IAM users, how are we going to accomplish that?
Right. So here's the second piece of the code. This is the attacker code, by the way. So user Bill doesn't have a very good password, so Bill is a victim here. So this attacker wanted to attach a policy to Bill's username to escalate his privileges, right? To elevate his privileges. The policy ARN in this case, you remember we abstracted policies into their own documents. This policy is called Power User Access. And I did mention it before. It basically gives you free reign over the environment with a few exceptions, like something like billing and things like that. You can't do that. But you can do a lot. Now, in the context here, that is not an approved policy for Bill to have because Bill doesn't require that level of access. So that's what we're talking about. Here's the rule syntax again. So we're trying to build some steam here. We're listening for CloudTrail calls, and we're listening specifically for 3 events: attach group, attach role, attach user policy. And of course, I've highlighted user policy because we've attached the policy to the user. So what do we do with it? Well, ultimately, the responder is going to detach that policy. Again, these are not terribly complex rules, but it says, I only approve these policies. If it's not one of those policies, get rid of it. So here we have Bill. Bill doesn't have any permissions at the moment. I will do sort of manually, because again, this stuff happens so fast. I'm going to do it manually. I'm going to attach that policy. And we're going to sort of recreate in steps the second part of that attack. So let's add permissions. Let's add the policies directly. And power user access. There we are. Next, add permissions. OK, simple enough. Now, what's nice about this is no matter if we're calling it through the button, through a Lambda function, if I were to pull up the CLI and do it,
the responder's still going to do the same.
The responder's going to do the same thing, even in the console. So let's see. We should see, if we refresh, should have no more power user access. Oh, we're getting there. There we go. Look at that. It did it. It responded. We got it. Level 2 responder.
Automated
or level 1
defense.
responder. Automated defense. Excellent.
Pretty good.
Cool.
All right, so we also don't want users to create custom policies for themselves. And that was another part of the attack, was the adversary trying to create a custom policy, apply it to the actual IAM user themselves. So the idea or the concept we're writing down in this case, do not allow inline IAM policies. How do we get it done?
Yeah, so right here. Again, so the bottom left is going to be the attacker code. and we are going to attach something called administrator access, and that policy variable in the string is up in the top right, which gives you star access, a complete access to everything. Beetle says no. This is another easy one because these are so much harder to control, to regulate than policies which have an ARN. So the rule here is no one should have an inline policy. We're not burning in anything. So what do we do with it? Well, first we need to listen for it. We need to find that rule. So again, we're seeing a pattern here. I'm not going to go through it all. We're looking for put user policy in this case. And what do we do with it? We delete the user policy. Very, very simple. Back to Bill. Let's add the inline policy right here. We'll do custom admin. I've already put it into the clipboard. Same thing.
Don't do it, Bill.
Bill, no. No, Bill. All right, so now we've got admin inline policy. We've got that star access. Let's see how fast we can get this one done. Inline policy. Entity does not exist. Was it that fast?
Come on, Lambda. You couldn't even.
Oh, that was even faster. Look at that. We killed that policy right away. Automated response.
I like it. All right, so other types of things that we would like to accomplish, our security goals, our objectives for managing the security of our AWS environment, again, expressing that in plain words, only allow EC2 instances launched from approved Amazon machine images, and make sure that they're from appropriate subnets and security groups as well.
So why? Let's think of a use case really quick, because it sounds really contrived. So if you've hardened some instances that you want internet facing, for example, right? And you have or a DMZ subnet, you make sure you don't want to put non-protected AMIs, or you want to make sure your security groups that are going into that subnet or applying to that EC2 are sound, right? So we're talking about hardening that. That's one use case. So what are we going to do? So whether it's CLI, API, console, whatever, let's just say we have these properties. We want to launch an instance with these parameters. We have the image ID, the AMI. We have the subnet we want to launch it into, and we have security groups. So now what's interesting? What are we going to listen for? A little bit different, right? So we're going to start to accelerate a little bit. This is the rule listening for that. Notice one thing I want to draw your attention to is the source. We're not looking at CloudTrail anymore. We're looking at all of EC2 as a service within your account. So anything that happens in EC2. Now, we've specified what's interesting for us, at least for the sake of brevity here. We want to know when it goes into a state of pending. In the EC2 launch lifecycle, pending is the very first state. So when you call run instance, it goes into a pending state. So now, what's really important about this, by the way, don't go to the next one yet. What's really important about this is all EC2 events are sent over here, are matched in this rule. That's different than the last ones because we're saying, oh, don't put an inline policy. So if there's an inline policy, it's going to be really simple. But we don't know yet whether the combination of parameters that have been input that has caused this rule to fire are valid or not. So again, this is just keeping a watchful eye on everything.
So we're going to evaluate every EC2 instance launch.
Every single launch is going to go through these checks, right? And if any of these checks fail, well, we have to do something about it, and that's up to us to decide. But again, every single EC2 instance will go through this check. Is it approved? That's an easy one, yes, no. If it is approved, is it in the right subnet? And if it's in the right subnet and it's approved, then let's see what security groups you're applying to it. That's the flow we're looking for. So we're going to take it up a notch. This responder that we're looking at is going to do those checks, right? So it's going to reach into what I chose to store my matching trio, my matching combinations in DynamoDB. So every single launch, this responder function is going to ask DynamoDB for approved data, and it's going to use the AMI as the key. And I'm not going to go into DynamoDB, but it's going to be really quick. So if that AMI doesn't exist, well, then it's clearly not approved. If it does exist, let's get the data associated with that and compare the parameters with what I said was OK. So this is my whitelist right here in DynamoDB. So let's go to the next one. What happens? All right, in this case, if it fails, right? So this is a failure scenario, and I'll explain what this is. This is code. This is code that is actually in the in this responder, and that is going to create an event. Well, wait a minute. We just had an event.
Right.
Launch a responder, which is going to create an event. We've completed event inception, an event within an event. That's what we've done. So if you break it down here, we've got some information. OK, time, that's fine. Source is going to be important. Keep that one in memory. Source. That's arbitrary. I named that. Source in the last one is AWS.ec2, right? I don't own that one. I own this one. So I said auto.responder.level1. Resources. I've chosen to pass along, this is what we're looking at. We're looking at the instance ID in this case. Detail type, again, that's something I define, and we'll see how that's used. And then, of course, the detail. Right? We want to know what we're talking about. Now, we've created a rule here for this event. What are we matching on? We should see some familiar terms, active response, for example, and autoresponder level 1. So we're watching for something, again, this custom event emitted from the first responder. When that rule is matched, that's a much more scoped down rule, right? Before we were looking for all EC2. Now we're only looking for if level 1 has a problem. So level 1 is your observe and report responder. Now we're going to go downstream, and we're going to call a level 2, which is going to terminate the instance. We've come full circle, and we've hit a failure scenario. Level 1, observe, report. Level 2, terminate the instance. So let's see that. Now, it's kind of like a cooking class. I've pre-baked some information, and one of those is that the AMIs on this list in this console are not, none of them are the approved AMIs, right? So we're going to do this, we're going to simulate this right now, or not even simulate, we're going to actually do it. So let's pick Amazon Linux. That's going to be the failure scenario. We don't even have to go through the rest of it, so I'm just going to skip to review and launch. So basically, I'm about to launch an instance. Actually, it's even got, this will actually fail the security group check as well. But let's see, let's just launch it. We don't even need it. So check this out. It's fast. Keep your eyes peeled. So this is the instance. You'll see it in pending state, right? Pending. We talked about that's the first one. We've already hit level 1 responder. Responder's deciding it's going to DynamoDB. And now let's see how fast. Wow, we've already got it shutting down. We've gone from level 1. We went from pending to rule matching to level 1 to DynamoDB, observe report, raise event, level 2 responder, and I don't know, that wasn't even a few seconds.
Nope.
And we're already shutting down this instance. Didn't even get a chance to come up. So that's what we're talking about. That's what we're talking about, automating this end to end. So what you don't even see is that it actually sent me an email as well and said something bad happened, but we're on it.
And it sounds a bit draconian, right? The idea that we're going to enforce our security policy at scale, and that we might have users within the AWS environment that can't launch EC2 instances, right? That sounds like a terrible experience. It's a great experience. It's a fantastic experience. It's a hell of a lot better than finding out 2 weeks later that you've been working with an EC2 instance in an environment and building your application. You finally got it working, and then somebody from security engineering comes down the hallway and says, hey, like, you got to start over. That's not a good experience. I would much rather fail early, right, in terms of trying to get an environment up and running and find out that it does not meet a security policy, that I can't get started and build a whole bunch of things and then have to start all over again a couple of weeks later because the security guys said, hey, it's wrong, right? Let's tell them it's wrong immediately. And let's get them started on the right path as soon as possible, right? This is a much better experience, and we can automate it. We can automate a lot of things, right? We've talked about taking a button and automating a pen test, right? We've talked about automating our security policy from the standpoint of making sure that nobody can launch instances except from approved Amazon machine images. And I'm thinking these buttons are cool. I'm going to build a whole dashboard of these, give them to the boss. He'll just be mashing them left and right. Security engineers in the office will just be running around with their hair on fire.
He'll have a lot of lunch dates if that goes all the way to ticket, by the way.
And they'll all blame me, right? But at the end of the day, Steve doesn't want a dashboard of buttons that he's actually pushing, right? Steve wants something to get done. He wants to make it so, right? And I think it would be much better if he could walk into his office and say something, right? And have it actually happen.
Alexa, launch security tools.
Welcome to your AWS Security Toolkit. You can ask me to perform security operations or gather information about your AWS environment by saying things like, run inspector on my production web instances, or give me a trusted advisor summary.
Run inspector.
Which environment would you like me to run inspector on? Development or production?
Production.
On which type of instances? Web, application, or all?
Web.
What rules package do you want to use? CIS benchmarks, security best practices, CVE, or runtime behavior analysis?
Runtime behavior analysis.
How long do you want to run the assessment?
5 minutes.
running an inspector assessment for runtime behavior analysis on production web instances for 5 minutes. I will send you an email when it is finished, or you can ask for the status by saying, "What is the status of my last inspector run?"
That's really good stuff.
Thank you, thank you.
Yeah, and we're not going to show that to the boss yet.
No, not yet.
Steve sees that, he's going to have that running in before you know it.
Yes.
So we talked about taking your ideas, turning them into actual code, thinking about the ways that you can actually get more training on this, right? We're talking about, what, a half hour or so of demos and sort of explaining where the starting points are and what the building blocks are. But there are a lot more resources that we provide in terms of helping you achieve these same objectives, right? So some of the things that we're running here at reInvent, game days are great opportunities for you to learn more about the environment, building response into your actual practice, getting practice in doing that. One thing that we also ran this year, in the first year that we've done it, the Security Jam. And that was pretty cool. A quick overview of what we accomplished there.
Yeah, we had a great time. So well, hopefully I had a great time, but I was administering it. But so what that was, it was actually in this room, and there were, was it 50 teams?
50 teams.
50 teams of 4 people presented with 10 challenges each. And challenges like kind of story problems that are in running AWS environments. And it says, here's the state of the environment, but here's this one thing that's wrong, or this couple things that's wrong. How do you remediate? So everyone got a chance to kind of get really hands-on to discover not just security services that AWS has. I mean, there are some really forward-facing services, like Inspector is a security service. Config and CloudTrail is kind of on the auditing side, but these are services specific to security, but also the security sort of tooling for your non-security services, like how to prevent data loss prevention from DynamoDB. DynamoDB isn't a security service, but you learn how to secure it.
Yep, and it was great. It was incident response, capture the flag.
Right.
So 10 different challenges. We had a leaderboard. Folks were fighting each other to try and get to the top of it. It was exciting.
Yeah, it was very cool.
And we're looking forward to doing more of those, so stay tuned. If you're looking for examples of how to monitor static variables or the environment itself using AWS Config, we have an AWS Config rules repository that's open source online. It's built for customers, but it's also built by customers. So we're not the only ones that are building rules for our customers to consume. We have customers that are actually contributing to that repo. That's on GitHub, and we hope that you find that useful and that you contribute back to it as well. And then, of course, the security blog. If you haven't been there recently, take a visit, check out some of the things that we're doing, and of course, we'll be announcing a number of other things, maybe related to the things that we've been doing today.
Maybe.
We talked about the presentations that we've given before. Remember to YouTube search for incident response in the cloud, intrusion detection in the cloud, wrangling security events in the cloud. It's all in the cloud. And of course, if you have issues or concerns, support is your one-stop shop for getting those addressed. If they do not have the immediate answer to your problem, they have internal escalation procedures that will get you to even the AWS security team if it's a security-related concern that you have. And then if you want to find out more about the AWS security team, you can check out our website.
Yep.
And then if you need to contact us, if you have questions or concerns that you'd just like to email to us, aws-security@amazon.com. The related sessions that we have associated with automating security event response, we highly recommend that you attend.
Bingo.
Yes.
I got bingo. Did anyone else get bingo for buzzword? Bingo, security automation. I just won.
I think we have a theme this year.
We do, yeah, we do have a theme. And so if you miss any of the awesome talks, and there are a lot of awesome talks, make sure you look for them on YouTube in short time.
And we'd like to give a shout out to some external resources. We have some friends over at threatresponse.cloud that have actually built an open source incident response toolkit. Visit their website, check out what they're actually building. These include things as data acquisition for memory, disk, any of the logs associated with an instance that's causing you some problems, isolating that instance, performing forensics on that instance. All of that is available to you in an open source toolkit, and there's a graphical interface to actually interfacing with that forensics environment as well. So check out threatresponse.cloud if you get a chance. So to summarize, previous talks and today, we've spoken about security agility, making sure that you can get things done in your AWS environment in an automated fashion. And ideally, with this presentation and the others that we talked about, you should be more prepared to achieve that than ever before. Remember, it's important to identify and express your security goals. Actually write those down in simple, plain language that captures what you want to accomplish. Work backwards from that, right? Deconstruct it just a little bit. And don't be afraid to actually express your security intent as code. And then this is a choose your own adventure world. All the services and features are there. Some assembly is required, but if you get stuck, make sure that you engage our support folks. And remember, when it comes to security event response, there are two ways to get practice,
but you only get to choose one. But wait. Alexa, ask security tools to get the last inspector results.
On your last inspector assessment run, security best practices on production web instances, there were 4 findings. 4 with medium severity.
Alexa, thank you.
That's not bad.
No, it's not.
You're welcome.
Thanks, guys. Thanks for coming.
Everybody. Remember to complete your evaluations. Thank you.
Evaluations, that's right. Please.